Today we are going to learn about lesson 2.7, dilations. This is the last section of the chapter. It is the last transformation you're going to learn for chapter 2. Okay, so let's define a few key terms. First being dilation. A dilation is a transformation in which a figure is made larger or smaller with respect to the point called the center of dilation. Okay, each dilation has a scale factor that comes with it. Scale factor is defined as the ratio of the side lengths of the image to the corresponding side lengths of the original figure. It can be noted as K. So a small k represents the scale factor. There are two types of dilation. Enlargement, which is when the image becomes larger, and reduction, which is when the image becomes smaller. Okay, tell whether the shaded figure is a dilation of the non-shaded figure. For number 1, the answer is yes, because if you look at that, you can see that the non-shaded figure, this first heart, it becomes larger. So this is an enlargement of the original figure. Okay, for number 2, we're looking at the non-shaded figure, which is this arrow, and is the shaded figure a dilation of the non-shaded figure? The answer is no, it is not. If you look at this, this is just an example of rotation. This arrow has rotated to become flat. Okay, number 3, is this shaded figure a dilation of the non-shaded figure? And the answer to this is yes. What happened is your original figure has become smaller. Therefore, this is an example of reduction. All right, we are going to draw the vertices of a figure and its image after a dilation with the given scale factor. The first vertex will be at -2, 2. The second vertex will be at 1, 2. And the third vertex will be at 1, -1. Now I'm going to connect my vertices. Now I'm going to dilate the figure with a scale factor of 3. What that means is I'm going to multiply every single ordered pair, each coordinate in the ordered pair, by the scale factor, which is 3. I know that it's 3 because right here, when you look at k is equal to 3, and k represents the scale factor. So for the parentheses, xy goes to 3x, 3y. Each x coordinate will be multiplied by 3, and each y coordinate will be multiplied by 3. So for a, -2, 2, that goes to a prime, which becomes -6, 6. For b, it's 1, 2. B prime goes to 3, 6. C is at 1, -1. C prime will go to 3, -3. So let's graph the new ordered pairs. Now I will connect the ordered pairs with a line. This is our dilation. The type of dilation, if you can see that the original figure has become much larger, this type of dilation is enlargement. One thing that I forgot to do that's very important is to label each vertex. So I'm going to insert the labels right now. Inserting the labels is very important because it tells you which one is your original figure and which one is the image. This clearly shows that the original figure is the smaller one. The larger figure is the image. Therefore, you can tell that it is enlargement. For the next problem, we're going to do similar set of directions, only this time we have different vertices. So I'm going to make a point at each vertex that is given. So the first vertex is at 4, 2. The second vertex is 4, 8. Then the third one is at 8, 8. And finally, the last one's at 8, 2. I'm going to connect each vertex with the line. And this time I'm going to label each vertex. Now each of these vertices are going to be multiplied by 1/2. So xy will go to 1/2 x, 1/2 y. So every x coordinate will be multiplied by 1/2 and every y coordinate will be multiplied by 1/2. D is located at 4, 2. D prime will be located at 2, 1. E is located at 4, 8. E prime will be located at 2, 4. F is located at 8, 8. F prime will be located at 4, 4. Finally, G is located at 8, 2. G prime will be located at 4, 1. I'm going to connect the vertices of the image with a colored line so that you can see where the image is since they overlap a little bit. You can see from the drawing that the original figure is larger than the image. So if the image is smaller, that means that this type of dilation is reduction. Number 6 says, a rectangle is dilated using a scale factor of 6. The image is then dilated using a scale factor of 1/3. What scale factor could you use to dilate the original rectangle to get the final rectangle? Explain. So when you're first taking the original image, you are dilating it by a scale factor of 6. You get an image, and then you take that middle image and take those vertices and dilate them or multiply each coordinate by a scale factor of 1/3. So you have the original x, multiply it by 6, then you take that number and multiply it by 1/3. So essentially, when you multiply this out, x is being multiplied by 6 times 1 divided by 3. Well, 6 times 1 is 6 divided by 3. It's being multiplied by 2. So we can just say that we can take the original figure's vertices, the x and the y, and multiply it by a scale factor of 2 to get the final image. Okay, for number 7, it says identify the type of dilation and find the dilation factor or the scale factor. So you can look at the two figures and you'll see that the original figure is inside. So inside you'll see A, B, C. Then on the outside of that you see A prime, B prime, and C prime. So right away you can identify that it is an enlargement. Now we have to figure out what the scale factor is. As for the scale factor, we need to compare the two sets of ordered pairs. We need to figure out how the original x and y coordinates got to the image x and y coordinates. So here A is at -2, -2. A prime goes to -4, -4. So in order for that to happen, all of these numbers were multiplied by 2. Let's see if that holds true for the other ordered pairs. So B is at 1, -1, and it goes to 2, -2. Well, once again, in order for that to happen, it was multiplied by 2. And finally, the last set of ordered pairs for C is 0, 2. C prime is 0, 4. Well, once again, it does hold true that in order to get from 0 to 0, you can multiply by 2, and 2 gets to 4 by multiplying by 2. So the scale factor here is 2. Okay, that is your dilation factor. All right, let's look at the next problem. This time the original figure is A, B, C. It's the larger one, and the image becomes smaller, A prime, B prime, C prime. Therefore, this is an example of reduction. In order to compare the ordered pairs, we first need to identify what the ordered pair is for each vertex. A is at 6, 6. B is at 3, 3. C is at 9, 4.5. Now we need to identify the ordered pairs for the image. A prime is at 2, 2. B prime is at 1, 1. And finally, C prime is at 3, 1.5. Now to find the scale factor or the dilation factor, you need to compare A's coordinate to A prime's coordinate. To get from 6 to 2, you have to divide by 3. But with a scale factor, you don't say you're going to divide by this number. You say, what do you multiply it by? So what is the same as saying divided by 3? The answer would be multiplying by 1/3. Understand that when you have a dilation that is a reduction, the scale factor has to be less than 1. Therefore, it has to be a fraction. Okay, so that would hold true. This is a reduction. You go from a larger image to a smaller image. Therefore, the scale factor has to be less than 1. We're going to make note of that at the bottom of the page as well. All right, let's see if this holds true. This scale factor rule holds true for the rest of the ordered pairs. So let's compare B to B prime. B is at 3, 3. B prime is at 1, 1. So if I took the x-coordinate and divided it by 3 or multiplied it by 1/3, yes, 3 would go to 1. Same would happen for the y factor. All right, let's compare C to C prime. So C is at 9, 4.5, and C prime goes to 3, 1.5. Well, in order to get from 9 to 3, yes, we can multiply by a scale factor of 1/3. And the same does hold true. 4.5 divided by 3 or multiplied by 1/3 gives you 1.5. So we now have identified that it's reduction with a scale factor of 1/3. I just want to make a quick note on the bottom of your page, or if you have room on the side. If you guys have an enlargement, the scale factor must be greater than 1. Realize that if you just take everything and multiply it by 1, the image is going to be the same size. But when you enlarge it, you dilate it and it gets bigger. Scale factor must be larger than 1. The opposite is true for a dilation that is a reduction. When a reduction occurs, the scale factor must be less than 1. So you are multiplying all your coordinates in your ordered pair by a number that is less than 1, by a fraction essentially. This now concludes your notes for 2-7.